Today I'd like to look at how do we rationalise the denominators of fractions involving surds. Before we get into some examples though, I want to make a couple of observations that are going to help us to do this. The first one here, for root 2 times root 2, illustrates that if we have an expression with a surd in it, and we multiply it by that same surd, so in this case we've got a square root of 2 in this one, and we're multiplying by another square root of 2, then we'll get a nice result. We know from this that 4 root 2 is the same as 4 times the square root of 2. And using our surd laws, we can combine these two into the same square root. Of course, 2 times 2 is 4, and I'll move this down. And we know that the square root of 4, of course, is 2, and 4 times 2 is just 8. Now, as we get good at this, you'll pretty quickly be able to go from this step all the way down there and leave this stuff out. But for the moment I've put it in there. The point that I want to make though is when I multiply by this square root of 2, because there's a square root of 2 already there, we'll always get this happen, end up with a square number, and our final result will be a rational number. Okay, so no more surds in the answer. And so we would say that it's been rationalised. Looking at this second example, here I've got two expressions, and we say that these expressions are conjugates. Okay. And what we mean by conjugates is that they've got the same terms in them. Both of them start with a square root of 3. Both of them end with a 1, but the sign in between is opposite. One of them's a plus and one of them's a minus. So we call these conjugate expressions. And just like with this one, when we multiplied by this square root of 2, when there was already a square root of 2 in there, we ended up with a rational expression. We're actually going to find a similar thing when we multiply conjugates. Last week we looked at the FOIL method for expanding these, so I'll just do this quickly. If you're not sure of what I'm about to do, go back and look at last week's videos. But here we have first terms, square root of 3 times the square root of 3. Outside terms are going to give us negative root 3. Inside is going to give us positive root 3. Last terms, 1 times negative 1 is negative 1. Tidying that up, I get 3 from this first term. Square root of 3 times square root of 3 is 3. These two are going to cancel because I've got a negative and a positive of the same thing. I've still got my minus 1. And so the final result for this one is going to be 2. And we note that again, this is rational. No surds. And these two results that we've got are going to be useful in doing what's called rationalising the denominator. And we're going to look at that in the next video.